We're going to look at many different ways that we can analyze numerical data. So numerical data would look something like this down here. For our example, we're going to look at this set of 15 exam scores. So we have this list of scores, which is recorded as numerical values. Now with this, we can do many things in terms of graphing and calculating. And what we want to end up with is a method of describing our numerical data, which is going to come through at the end as about a 2 to 3 sentence conclusion that'll summarize our findings of our numerical data. So pieces that we want to include in this kind of summary that we get for our data is we'll want to describe the shape of the data. This will tell us about trend and what's expected and kind of the overall behavior of the data. And with that, we'll need to look at the graph of the data. So in this video, that's what we're going to look at, is creating these graphs, and then we'll discuss reading the graphs. Another piece we'll want to describe is center and spread, and usually we'll describe these together. Center gives us an idea of what's expected for our data. So what's the expected outcome when we have a data value? And then for spread, that gives us the idea of the variability of the data. Is it really close together, which would suggest very little variability, meaning that then if we have some expected value, we should be very close to it. Or if there's large spread to the data, so it's kind of occurring everywhere, then that tells us that we can predict, we can have this expected value for our data, but maybe it's not that reliable because really our data is so spread out. So those features are important. And then another piece that we'll talk about is unusual features to our data. So this can come through in shape. So something we'll discuss is bimodal or multimodal. Another piece that we'll discuss are outliers, which are basically extreme data values. We want to take note of those unusual features because they can affect how we describe the shape. It can also affect the numbers that we get out to evaluate the center and spread of our data. So we want to have part of our conclusion these extreme values and making sure that we recognize them. So in terms of graphing, we're going to look at two types of graphs. The first one's going to be a dot plot, and then the second one will be a histogram. Now, a dot plot is great for small data sets. So in a dot plot, we get to see individual values and how they behave. So with our data set here, we have these numerical values. So the first thing we need to do is set up a number line. So in setting up a number line, what you'll need to do is make sure you can see all of the data values. So with this, check your minimum and maximum value, and then create a scale across that data set. So something I did here was I set 30, and I knew I had to see up to 100, so I used these jumps of 10. Make sure the scale is consistent, because that'll really bring through how the data spreads out. So I wouldn't want to change, like have this be a jump of 10, and then do 41, 42, then do jumps by 1. So what we'll do is draw a dot for each data value. And we'll just place it along the number line, specifically on top of the number line. So 31 will go about right there, 62, 65, 70, 76, 81, and then 82, what we'll need to take note of is that there are two data values for 82. So what you're going to do is stack repeats. Meaning at 82, I've plot one value and I need to show that I have a second data value. 87, 88, 89, 94, 95, 98, 100. So with this, we can get an idea of trend. We can see where most of our data values are lying. We can see how disconnected that 31 is from the rest of the data set. So that starts to get at the idea of a potential outlier for this set. And drawing this for a small data set, no problem. As you can imagine, if I had 150 exam scores, then that would take much longer and it would be harder to see trend coming through. But this gives us an idea of what's happening on an individual basis. So if we have larger data sets, that's where a histogram is fantastic. And this is what we'll work with more often in this class, are the histograms. So histograms, they end up grouping the data. So this groups the data into bins or classes. And for what we're doing in our class, I will tell you what the bin width is. So in this case, we're going to set a bin width of 10, which will actually be similar to how I set up the dot plot up above there. And there is a way of calculating ideal bin width for a data set. There's a formula for it, but for our class, you can just rely on use the value that I tell you. So scaling and labeling our graph. So what we're going to do is we'll have a grid similar to what you would see in an algebra class. We're going to just be working in that first quadrant since we'll only have positive values. And what we're going to do is set up our x-axis or our horizontal axis and set up our y-axis or our vertical axis. So for the x-axis, what we'll have horizontally, this will be mapping our actual data values. So if I needed to label the x-axis, this will be where I'm actually looking at the exam scores. Along the y-axis, what we'll be collecting is frequency, which basically means for frequency, that's just another word for count, or how we'll translate it is number of data values. So along the y-axis, I'll go ahead and label that as frequency. So along the x-axis, we're going to use a bin width of 10. So what that means is I would go 10, 20, 30, 40, so on and so forth. And I'll label this more clearly in a moment, but something I want to bring up with is for our data set, we can see we start at 31. And while this is a perfectly correct way to label it, what you'll notice is with this graph is I would have all of this empty space between 0 and 30. So what we could do is, to make the graph a little more clear, is we could just jump ahead to 30 and start labeling there, which isn't completely necessary in this case, but I want to show this notation for if it does come up. So I could jump ahead to 30 and then go 40, 50, 60, 70, 80, 90, 100, and 110. But what you want to take note of here is that I have changed scales. So you can see here this distance represents 30, and then I change it to a distance of 10. And in math, that is not okay. So we need some special notation here to just show we jumped ahead and there isn't any data in that area there. So what we do is we use a line break, which is just basically a zigzag across the number line there. And that's just a symbol to show between 0 and 30 there isn't any data, and then we start looking at our data at 30. Now frequency is going to count the number of data values in the bin. So what we'll have here is a bin for exam scores from 30 to 40, and then we want to draw this bar that goes to a height that matches the number of data values there. So let's go back to our data set. So what we're going to do is break this into groups of 10s. So I want a bin for the 30s, 40s, 50s, 60s, so on and so forth. So for 30s, I have one data value, nothing for 40s, nothing for 50s, 60s, I have two data values, 70s, two data values, 80s, six data values, 90s, three data values, and hundreds, one data value. So how we're going to draw this, and to label my frequency axis, what I can see is I need to go up to a frequency of at least 6. So numerically, I'm just going to use ones here. So 1, 2, 3, 4, 5, 6, 7. So for the 30s, I had one data value. So what I'm going to do is draw a bar between 30 and 40 to a height of 1. So this shows one data value in there. Then nothing for 40s, nothing for 50s. So we leave those two spaces blank. 60s, there are 2 data values. 70s, 2 data values. 80s, 6. And then 3. And then 1. And this would be our histogram. So this is great for seeing large data sets because it ends up grouping them, and then all we have to do is adjust the frequency. So if we did have a data set of, say, 150 values, then maybe you see something like 10, 20, 30 along our frequency axis. But it's an easy way to scale and see all of our data in just one big graph and seeing it clearly. And we also get an idea of trend. We can still see that there's this large amount of data set between 80 and 100. We can also see this disconnect of that value of 31. We could get a more descriptive histogram by changing the bin width. Say we change the bin width to 5, then we could see maybe even a little more detail, and that's something we can play with. Something we should take note of is how this number line is working. So this is 30 to 40, 40 to 50, and let's specifically look at 60 to 70. So 60 to 70, you can see our data values. And if you think about in terms of our dot plot, 60 to 70, we're basically seeing what's graphed here. But let's take note of what's happening specifically with the number value of 70. So with 70, that's being grouped into this bin on the right-hand side. So while the numerical value of 70 is landing kind of on the edge of those two bars there, it's being counted in the right-hand bin. So this is called the right-hand rule, which just means a number on the edge of a bin goes to the right-hand bin. So for data values that are actually on the number line that we're seeing there, will go into the right-hand bin. So while we have this bin that looks like it's 60 to 70, really that bin is containing values 60 to 69.9999, repeating forever. So with that, 70 is actually included in the next bin on that number line. So histograms are great. We can see overall what our data is doing. We don't see an individual basis like we do with the dot plot, but we're going to look at histograms and how they summarize data, as well as reading them and using that we could read this and see there's one data value between 30 and 40. We can't say exactly what that data value is without seeing the original data set up above, but we can get an idea of how these values disperse. You can also get an idea of sample size from these histograms because we have one data value, 2 data values, 2, 6. So you can add up the frequencies to get an idea of the sample size of your original data set. So there are ways to read the histogram without actually seeing your original data. So what we're going to do next is look at describing the shape of the data in your next video.